Purpose of this video is to demonstrate the sample mounting system developed by Radiant for the precision nano displacement sensor. The purpose of this special mounting system for samples is to provide a robust stationary foundation for the user to bring wires into the sample without torquing the piezoelectric element. I've removed the piezoelectric chuck assembly from the microscope to make it easier to see in this case. The system consists of three parts: a brass cylinder with a threaded hole, a plastic chuck with two threaded holes, and specialty PCBs. The simplest form of sample mount is to place the brass cylinder onto the piezoelectric element. The simplest form is the plastic chuck alone with its set screw, which can be placed over the cylinder and the set screw tightened. I can use this to slightly torque the brass cylinder to make sure it stays tight on the piezoelectric element. A sample can be mounted to this and tested as the user desires. Now, also can use specialty PC boards to make it easy to make electrical connections. I've removed the plastic chuck from the system, or from the chuck assembly, and I'm showing here a custom board as received, as you will receive it in the shipment. This custom board has solder points, solder pads for the sample. The sample can be mounted in the middle of the board. Wires can be soldered between the sample and the solder pads. The solder pads go to these solder points, which allow you to bring in wires that will then go out to coax cables to the tester. The tabs are here for commercial AFM systems to stretch across larger gaps. They can be broken off using perforations. This is what happened on this system. I've already removed the external tabs. Notice the location of the cantilever arrow, which indicates from which direction the cantilever should come in from the light lever. The two holes in the PC board are designed to align with the threaded holes on the plastic chuck. Once the screws are in, there's a flat surface where the sample can be placed, so the sample can be quite large and then soldered to the pads. Adding the sample to the chuck is very easy. Just slide it over the brass knob, align the cantilever arrow, and then tighten the set screw. Once it's done, the sample can be removed by removing the set screw, moving the chuck. You will also receive in your sample one specialty board with a PFM reference sample, as we call it. And this is a 1 micron PZT film on a die mounted on a TO18 header that will be placed in sockets on this board. The sockets now, or the solder points at this point, now go to specific pins on the TO18 header for which you'll receive documentation. The die itself has a membrane, piezoelectric membrane, that will move at least as much as 1 micron at 20 volts, and also has a flat, thin PZT film capacitor on the substrate, which will move about 15 to 20 angstroms at 20 volts. With these two different elements, you can test both modes of the PNDS once you have it assembled.